the important topic, that is Cartesian product. So let's get started. Sometimes we want a collection of ordered pairs, right? Sometimes we are interested in finding a collection of ordered pairs. Let's say we are interested in finding all possible combinations of x and y coordinates where x and y values should not exceed 3. Okay? We are interested in finding all possible combinations of x and y. That means we are interested in pairs. We want all possible combination of the pairs x and y where the values of x and y should not exceed 3. And this is how the collection looks like. Here we have all these pairs where the first value of this pair represents the value of x and second value of the pair represents value of y. Here you can see this pair consists of two values, that is 1, 1. Then we have 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. These are all the possible combinations, right? Here a comma b for any a and b is called an ordered pair, okay? Now why I'm calling this an ordered pair? Because let me tell you that order does matter. Here the order of a and b does matter, okay? Please note that a comma b and b comma a are not equal. Let's try to understand this with the help of an example. Why is this the case that a comma b is not equal to b comma a? Here you can see in this graph that this point is 1, 3 and this point is 3, 1. You can clearly see that 1, 3 is not equal to 3, 1. Therefore, in an ordered pair, order does matter. Okay. Now let's discuss the definition of Cartesian product. Let A and B are two sets. The Cartesian product of A and B, denoted by A cross B, is the set of all ordered pairs A, B, where A belongs to capital A, that is set A, and B belongs to capital B, that is set B. In other words, we can say that A cross B is equal to a set of all ordered pairs, okay, ordered pairs A, B, such that small a, that is this element A, belongs to capital A, that is set A, and small b, that is this element B, belongs to capital B, that is set B. As simple as that, okay? Now let's discuss one example related to Cartesian product. What is the Cartesian product of A, that is this set, and B, this set? Here in this set A, we have two elements, 1 and 2, and here in set B, we have 3 elements. We want to find the Cartesian product of A and B. And let me tell you, this is very simple. Here we want to find out A cross B, right? A cross B must be equal to, we can form all the different combinations. We can take the first element of A and we will take all the elements of B. Here you can see that we can take 1 as the first element and second element can be A. We can take 1 in the first place and B in the second place, then 1C. Similarly, we can have 2A, we can have 2B, and we can have 2C. So these are all the different possible combinations, right? Now here is one important note. A cross B is not equal to B cross A. It should be well noted that A cross B is not equal to B cross A. Why is that so? Let's discuss this with the help of an example. Let us suppose that A represents this set, that is 1, 2, and B represents this set 3, 4. What is A cross B? A cross B is equal to all possible combinations where the first element of an ordered pair must be an element of A and second element must be an element of B, right? Here we can have 1, 4, then we can have 2, 3, 2, 4, right? These are all the possible combinations. In this set, we must have ordered pairs where the first element belongs to B and second element belongs to A. Let's take the first element 3 and second element we can take 1, then we can take 2. Now let's take the second element, that is 4, and 1, 4, and 2. These are all the possible combinations, right? Here is one more important note. For any two non-empty sets A and B, if there are n elements in capital A, that is set A, and m elements in B, that is set B, then the number of ordered pairs in A cross B will be nm. This is very important, okay? There must be nm elements in this A cross B set. If there are n elements in capital A, that is set A, and m elements in capital B, that is set B, then A cross B must have n into m, that is nm elements. For example, we can have a set A with these elements A, B and set B with 3 elements P, Q, R. Here the number of elements in A cross B must be 2 into 3, that is 6. Why is that so? We know that in an ordered pair, first element of an ordered pair must belong to the first set and the second element must belong to the second set. Here in this case, we have two sets A and B and we are talking about A cross B. This means that the first element of an ordered pair must belong to capital A, that is set A, and second element must belong to capital B, that is set B, right? We know that there are two elements in set A. So there are two different ways in which we can fill this position. And we know that there are 3 elements in set B. So there are total 3 ways in which we can fill this particular position. For every element of A, we have 3 elements of B. So it is clear that there are total 2 into 3, that is 6 elements in A cross B, right? Now let me tell you one more important point. Please note that phi cross A is equal to A cross phi, which is equal to phi. Why is that so? From the definition, we know that phi cross A is equal to a set of all ordered pairs where A belongs to phi and B belongs to capital A. This is from the definition of Cartesian product, right? Here A must belong to phi and B must belong to capital A because this is phi cross A. Now let me tell you that it is not possible that some element A can be a member of phi, right? Therefore, there is no such pair A, B where A belongs to phi and B belongs to A. Thus, we can say that this set is equal to phi. It is not possible, right? There is no such pair A, B where A belongs to phi and B belongs to A. Therefore, phi cross A must be equal to phi. Similarly, we can say that A cross phi is also equal to phi with the same reasoning. Here in this case, small b belongs to phi. And we know that there is no such small b or element that can be a member of phi. Thus, we can say that A cross phi is also equal to phi. Therefore, it is clear that phi cross A is equal to A cross phi, which is eventually equal to phi, right? So this is all about Cartesian product. And in the next presentation, we will try to solve some problems related to Cartesian product. Bye-bye.